first off, a smart building or intelligent building is going to be different for everyone. But when we look at the core of how a traditional building is designed and deployed versus how an intelligent or smart building is designed and deployed, there's where the key fundamental differences are. Traditional construction, we refer to that a lot as siloed construction, where each of the individual systems is designed kind of in its own bubble, and then it's brought to the construction site and fit in around the other design pieces, whether it be the HVAC, the conveyance equipment, the lighting systems. All the different systems in the building are really, they're designed without regard to the other systems in the building. When we look at a smart or intelligent building, where first off, we're leveraging technology to benefit the end user, the occupant of that building, to reinforce their business drivers and hopefully make them a more productive, more profitable environment with lower operational costs and lower costs to construct. And that starts with an integrated design where all of now the design disciplines are working together around an intelligent building methodology, so that all the systems are tied in together through perhaps an integration platform and are able to share the data between the individual systems to optimize their performance for the benefit of the building and the occupants. In my opinion, it's an integration platform. The ability to take all of the systems and tie them in together. From there, it goes out to the infrastructure that ties all the systems in, the ability to bring that data, the ability to bring that power and control from the core to the edge. We utilize power over Ethernet quite a bit. And I like the term BAOS. It's building as an operating system. It's the thought process of designing the building to be agile as an operating system. So as the external needs of that building or even internal needs of that building change, things like edge devices and software applications become very plug and play. And I know my team is sick of hearing me say this, but it's a lot like a smartphone. The ability to go to the App Store, download an app, and it just works in the building to solve a problem. And in this day and age, that's things like social distancing, that's cleaning procedures, and so on throughout the building. It really depends on the motivation. If you're in proof of concept is the term that is thrown around most often, the POCs in the industry. If your goal is just to evaluate a certain piece of technology, that can be an effective approach. The problem I have with proof of concepts is you don't really achieve the economy of scale when we're looking at consolidating all of the systems within a building. If you're doing it in either a portion of a building or perhaps it's a new build and you just want to try one piece like networked or PoE lighting, you don't get the full breadth of what an intelligent building is. And oftentimes end users are turned off by the cost factor when you're just deploying a little piece. The big savings when we're looking at intelligent buildings and the big performance benefits come from the ability to tie all the systems in, not just deploy a standalone system. All that is a siloed building with an intelligent component when you're looking at proof of concepts and scaling that down. Yeah, I think the infrastructure really plays one of the most important roles, because when we look at an intelligent building, essentially we're turning it into data. And that's why the things that Gary talks about are so important, because all this data comes back to a data center of some sort to be able to be shared with other systems, with the folks that are monitoring and making the adjustments in the building and so on. So without that ability to transport the ones and zeros, then there is no intelligent building. And we look at the different types of infrastructure, the different grades, I'll call it, of infrastructure. And, building components are broken down into a couple of categories. You have your high bandwidth, high power applications. You have your low bandwidth, low power applications. And there's where you have to consider what the right infrastructure is. I always say a PoE clock is going to be a PoE clock forever. You're probably not going to need a 10 gig solution to support a PoE clock. But when we look at things holistically, may that clock change 10 years from now? And if that's the case, then you do want a higher performing infrastructure to make sure that you have the bandwidth and the power delivery capability for that next generation. Again, going back to that building as an operating system thought process, you want to be able to plug and play anywhere within that building to take advantage of current and future technology. As someone who really in our organization is a value add customer, the last thing I want to see our customers in is a position where they have to really give deep thought to, do we want to deploy a technology that is going to help our business, knowing that we're going to have to replace a portion at least of our infrastructure. So if we look at that more robust solution from the beginning, then that takes that portion of the thought process out of the way, and you can really evaluate technology for the technology benefit aspects, not because there's so many other issues within the building that have to change. Yeah, absolutely. Again, there's the obvious, like I mentioned, things like the social distancing. We're seeing UVC disinfecting solutions that are coming into play here. But I really think the takeaway is, again, the BAOS, the building as an operating system, because, it's easy to look back at this pandemic, and maybe we're not looking back yet, but it's easy to look at what we've been through so far and say, hey, these are the things that we need to do or should have done. But I don't know what's next. No one knows what's next. But what we do know is our buildings need to be able to adapt and adjust quickly at a low cost. And the more we can design them similar to smartphones with that plug and play capability, the easier it will be for these environments to adjust to social conditions, weather conditions, emergency scenarios, any of these different types of situations that may occur. The ability to be dynamic is absolutely paramount. The Siemon company, as I'm sure it's been outlined thus far, we manufacture layer 1 infrastructure. So that's all your categories of cable, patch panels, connectivity, everything in that transport layer. We also value our ecosystem of partners. So as we are leading these conversations in intelligent buildings, we have the ability to bring in partners that can actually assist us to deliver. One of the things that we've learned in the smart building or intelligent building space is it truly takes a village. There's no one company that can do an entire intelligent building for you. So where we specialize in the infrastructure, and our componentry has been really customized to optimize things like power delivery, data transfer, all the important core elements of an intelligent building. We also have a vast ecosystem of partners that can help design intelligent buildings, deploy intelligent buildings, different edge device manufacturers and active gear, and so on.